uh, I will demonstrate using Python for the land cover classifications using the satellite imagery. For practicals, before that I will explain about the flow for this processing, and I will show the land cover classification using two machine learning algorithms, which are random forest and support vector machines. So first, now I will demonstrate using the Sentinel-2 satellite image, and okay, we can see from here we will classify using the random forest algorithm first, RF. But before we use machine learning for our classifications, we need to do some steps in Python in order to process it and get our output or the accuracy result. So the first step is we need to first import the Python libraries. A few of the Python libraries need to be imported. So such as for example, GDAL, NumPy, Matplotlib. So if later on you got the chance, or you would like to go into the Python processing using Python, first every time you need to import the Python library first, because each of the library have their own module and functions to execute the operations. So first, to import the GDAL. GDAL is the Python library that is specialized into the geospatial processing. Since we are in the geospatial field, so this GDAL can be considered geospatial libraries. It can read many sorts of the geospatial data, whether it is in the raster format or in any kind of the vector format. So before I go deeper, I will show to you guys just a moment. I will show to you guys about that. If let's say in future, you will use Python programming for your processing task. So if every time when we want to use that particular libraries, you can search it through the pypy.org, which is which can provide you uh, with the overall documentations of that particular geospatial library. For example, if I want to know more about the information for GDALs that I will be using, so just tap GDAL and then go to GDAL 3.5.03, and here actually there's some small descriptions to explain about uh, the use of that particular libraries, and you can go to the main page of that particular library by select the home page. Then it will link to that a particular library. So this is the main page of the GDAO. You can get more informations in detail when in very detailed informations. So you can read it later. So same as usual, you if you want to use any if you want to know any of the Python library, you can check it through PyPy. So okay, so this is the first step. So we need to import the library. So this is the first step. Every time when we want to execute any task in or process any task in the Python. After that, for our geospatial processing, we need to import the relevance or the satellite imageries with the ground truth or the reference data. So we that's why we need to use GDAO to implement or to open and read our satellite data, satellite imagery, as well as the vector data, which is the reference. Uh, so we will use them during the classifications. And after all, this is just a small functions from this GDAO. We can see that we can read it. We need to read the size of that image in order to proceed to the next. And to display them in a graph, we need to uh, we need to use the matplotlib, the functions or the module in the matplotlib to plot the uh, to, to plot the image or to display the image. So after that, this is for this step overall is we just need to make sure that the data has been read through this display or visualizations. So after that, you can just click run. So you can see from the left is our satellite image, and from the right is our eye training data or reference. So second step, if you want to know some of the nature of the data we have provided, so the data such as the training data contain how many classes and the size of the dimensional size of that image and also the reference data. So we can execute that. At here is so we have 15,687 samples with 6 classes. So six classes, actually 6 classes. This is at the this area is the oil palm plantations area, and having having the oil palm as a class that has been divided them into immature, matures, and other features like the waters, urban, and bare soil build up as well. So you can see from here, at least we can verify that our data, the input that we provided is correct, and we can also know the size of that data and also the reference. So okay, so I we have okay, at this moment we have at least know some of the basic information of that image or the data we provided. So now last time we have come across with the workflow or for the land cover classification using Nmat and Avias. And some of their method is applicable and similar to our following steps. Since we in the following step we need to do uh, some sort of the change splitting our data into the 70 or 30%. So here we can partition them in the for the test data we put it or define them as 0.3 or 30%, and automatically the training data will be 70%. Okay, so if you want to view our shapes of our training data set and testing data set, we can view it here by having the dot shape, so we can know the size of the image and also the reference. And now we can come into the image classifications, classifications using certain machine learning algorithms. So by using the by using the sklearn libraries uh, to import the random forest classifier, since now we want to use the random forest algorithms to classify our land cover classifications. So dot fit here is to fit our defined algorithm, which is the random forest, into our model before before the real implementations. And after we have developed the model, because this step is to show that or to indicate that we have developed the model or built the model. So now our it come to our predictions. So on we need to predict it in into our test data. Since as we can see here, we are using train data. As I previously we see that we have split our data into training and testing, right? So X train, Y train, which is or X is indicate the satellite image, Y is indicate the the reference. So so now we need to use the test data for this uh, making the predictions or to come or to evaluate the model performance. So here, okay, so here we use the overall accuracy to predict it. So actually the accuracy is quite good, 99.81%. And we can also plot the confusion matrix. Okay, so after that you can see we have come out with the confusion matrix that give us the overall accuracy. And now we can provide the classified image by giving the image for these predictions. And after that, at the last step, we can visualize using the functions to visualize the image. So this is the overall classified image. So as we can see that the classified image is quite good since the first class is water, second base soil, third is forest, immature, mature, and build up. So basically, this is the color palette we provided. So this is the output for the random for the classifications using random forest algorithms. So they still it still have some improvement. It still needs some improvement, but overall, the classify the visualizations is quite good. Okay, so I have demonstrated, and actually we can adjust to make it bigger. Okay, and now okay, so now we have seen how to how to use random forest to classify our satellite image using Python, and I think you all have some overall idea, just a rough idea on the processing or the workflow. And now we will go uh, to use another machine learning algorithm, which is support vector machines for our classifications. And as I explained previously, the workflow is uh, is is similar. Just sometimes we need to do some of the feature engineering, such as the normalizations or scaling. We will see through these support vector machines. Okay, so the step, as we can see, is the beginning step is still the same. Every time we need to import the necessary libraries, and most of the times geospatial libraries such as GDAL uh, is working with the NumPy, since NumPy can read the dimensionals array of the image and display them in the numerical form, and and also matplotlib we will also dealing with, even though it can be also applied to other tasks out of this geospatial processing as well. For example, because matplotlib is more onto the displaying, visualizing the image, graph, histogram, and many others. So the first step is to import the library. And the second step is to read our image and also our reference that we have provided. And the third one is to uh, is to in, is to read the raster size data and display them using the matplotlib. So this is the very first step. Since we want to know, we want to display the data first. Okay, so this is we can see this is the image that of the satellite data. Yeah, we can change here. This is actually satellite Sentinel-2 images. Okay. And it's still the same with the previous one. So that's why if we familiar with at least one process workflow, you can do the repetitions in your memory. So it can be easy for your other tasks if you execute or implement using other machine learning algorithms. So the second step is to uh, is to is to read or to to the to extract basic informations of the image and also the data. Okay, so this is this is the second step to display to extract some of the basic informations. And what is different from just now? Now we would like to try, or we would like to try to do some scaling or normalizations in our pre-processing stage. And I think I'm sure that in some of the algorithms that you have used in the IaaS plugin or mmap, it also have this kind of functions. And because this can increase or the accuracy of our classifications if we do some data cleaning in our pre-processing step. Okay, so as you can see, I use standard scaler so to scale them into certain range 0 to 1, ranging from 0 to 1. And now, as usual, uh, for the data, we need to do data partitionings and to split our data into training and testing. So this is quite a very general step in the machine learning workflow. And after that, we can read the informations based on our data, training data and testing data set. And uh, now we will import the sklearn to implement the support vector machines. And here, as we see, SVM functions has been used, and the kernel here we provide linear and C, and you can also provide other parameter as well. And after that, just uh, this code is just to instantiate the models, and after that, this code is for to feed the model and to feed the model in the model building. Then okay, so same as previous one, we use the training data. Now we come to use we need to do predictions on our test data. And let's see the accuracy. 89.76. Okay, so we can see if with the support vector machines, the performance is lower than the random forest, which only achieve 89.76% when compared to these previous algorithms, random forest. So we can also execute the confusions matrix, and later on, the step will still as usual. We need to reshape our image to for this image visualizations. Okay, so the last step is to visualize the output or classified image. So I think the workflow that I explained, or the workflow in the Python programming is similar or you can have the overall view and compare them uh, with the Avias or mmap plugin you used before. But this is a general workflow since we can always optimize or increase the accuracy by adjust by optimizing the parameters for the certain algorithms. So every algorithm has their own uh, optimizations parameter. We need to really study on that. So you can also apply that in your work. And uh, and any questions from you guys? Seems
No, sir.
so. Do you see any advantage of using the Python? You can do the comparison since before that you have used the IaaS or mmap. Maybe someone from your side can provide your own opinion. How about Anjali? Anjali, after these demonstrations, what is the difference using the Python programming for this land cover classification with the IaaS or mmap you did before?
Mhm. Okay, sir. So basically, I think the main differences is the hyperparameter optimization, because in Nmap, right, we have the plugins actually the hyperparameter default, means that the plugins itself, like it selected the best, I mean the optimal hyperparameter. But in this, I think in this Python, we can like control it by ourselves, like to increase the accuracy, just like Sir said, we can like change the hyperparameter. I think that's the main difference. I think that's all.
Okay, yeah, that's great. As we have figuring out through these demonstrations, we can see that by using the Python programming, we have it have the advantage such as high flexibility, since since the plugin that we use has been invented by the developers. So certain settings has been configured as default. So uh, with this Python programming, we can flexibly adjust the or configure the parameters, and it can also not only can be hyperparameters but others many things as well as we prefer or we like. So this is one of the major advantage using the Python programming. Yeah, after so I encourage you guys can explore more on this even after your graduations. Okay, I think that's all from me.
Okay, Yuhao, thanks a lot, okay, for demonstrating the use of Python, okay, for remote sensing image classification. Okay, so this is only just a very simple demonstration. Actually, there are many things that you can do. Just now, you have shown how many algorithms you have? Two, isn't it?
Yeah, to super vector machine and random forest.
Okay. In a demonstration, you have used only two at the moment, but of course, we can also try other algorithms as well as testing the capability of deep learning, for example. Okay, so there are many things that you can do. Okay, this is very interesting because at the moment in Malaysia we don't have many experts that can use Python. Okay, to do programming and performing we call it end-to-end remote sensing processing in a programming environment. So this is a very important skill. Okay, so the demand is very high and also the salary is quite high. Okay, for those who can do programming, okay, using Python to process data. Okay, for example, remote sensing data and so on. Okay, so that's why you can see like what Dr. Obe has mentioned last week. Data science is a field that is having a very high demand at the moment, and data science is a field that is open for everyone. Okay, it's not only exclusive for those from computer engineering or computer science, but it is open for everyone because data science is useful for basically for any fields in the world. Okay, data science can be used for anything, right? So um, it is not it's not very difficult for you to learn programming actually and the principles of data science. I think if you spend, let's say, an intense, what you call it, if you focus for about 6 months, taking maybe some short courses on Python, okay, you can master the language. Okay, the thing that you need is focus and also the time. Okay, so I think uh, that's all basically about the demonstration on the use of Python, okay, to process remote sensing data. Okay, thank you, Yuhao, okay, for your nice presentation. Okay,
Okay.
so I think that's all basically, okay, for this okay, for this course this semester. Okay, so anything you want to ask? Any final questions that you like to ask about the course or the exam in general? Okay, so if you don't have any questions, can I take one final group photo?
Yes.
Just now, some students are missing.
Doctor, may I ask for the final exam, what will be the format like? Maybe of how many questions?
If I'm not mistaken, there will be like 2 or 3 questions for part A, and in part B you have options. Okay, normally you answer only one. Okay, in part B you have some selections. Okay, so it's an open-ended kind of question in part B normally, and you maybe have to answer only one. Okay, so the exam will be physical, isn't it? It's not face to face, it's not online, so it will be physical in UPM. Okay, okay, so can we take a group photo? Okay, so since this is the last class, okay, okay, this is the last record of your attendance. Okay, also